I believe the rest are yet to join. Let's just wait.
Hi everyone, good evening.
Hi Mugdha, how are you?
I'm fine, Siddha. How are you?
Yeah, I'm doing good as well. Thank you. Hi Rohi.
Hello.
Hello. Uh, Assuming you can hear us, let me share my screen, and you should be able to see a notebook or a notepad.
Yeah, notepad I'm able to see.
Yeah. Okay. Okay. So before we go ahead, just a quick recap of what uh, we were doing until now. So we started with the introduction of Python. This is there in our portal already. Then we had to cover the introduction to SQL, but we skipped this because inside Python itself, right, we had a lot of such, let's say, constructs which leads to data analysis. So we moved over to statistical methods, and we looked into these with somewhat Python code. I'll not say we have written extensive code, because as much as possible, the criteria that we have followed is that we have used things which are already in place, right? Which libraries are already there, right? We have reused them as much as really possible. A few cases here and there only for, let's say, data reading and data preparation kind of things. Yes, for that we have done some kind of coding, right? But then we started with the advanced analysis, where we looked into ANOVA, the analysis of variance, and we covered to a good extent on the regression analysis. I just wanted to mention why I'm saying good extent is because there are two other methods of doing regression which we did not cover, and there is an intention, there is an intuition behind it. Why I did not cover that, why we skipped it, is because we have looked into simple linear regression, multiple linear regression, using a very simple use case where we have used advertising data. We tried to figure out what advertising channel is really leading to a good sale or increase in sale in the quantity. Yep. So after we have looked into that, we were supposed to look into dimensionality reduction and a couple of ways in which we could do regression in a better way. They are otherwise known as ridge and lasso regression, but clearly we have skipped them as of now, and there is a reason. It uh, deals with how we visualize or how we ascertain multidimensional data which is like a sandwich. So if you see, or if you can imagine a sandwich in front of you, it's like there are layers. Okay, so unless and until we understand those layers in mathematical terms, we may not be able to understand what is ridge and what is lasso, and hence its implementation will be kind of black box. So that's why we have skipped it, and we have also skipped dimensionality reduction, because we need to go back to the basics and we need to understand, let's say, how we are going to process, store and get data. So this is the part that we are going to complete, and then we are going to get back, right? But before we really do this, maybe one thing that we or I would like to ask is, let's say you may want to write it into the chat window if that is easier. So if you can just write down what level of, let's say, what level of knowledge on SQL you all have. I mean, is it a very basic level, or is it kind of, let's say, you're already working in some BI or, let's say, data warehousing team? If you can just write it down, then accordingly we can plan it out. Or you can speak as well. Okay. I've already got a response from Mugdha. What about you, Rohit? Okay. Okay. I know about Sarangs already, so I'm not expecting an answer from him. But that's fine. I see there is a mixture here. So let's just start with what we need to know, and then we can redirect to different, let's say, learning resources. Now what I wanted to start before even going on to SQL is that why are we really going to use SQL when we already have, let's say, Python and all these things, right? And why we are really going to use SQL is because of a very simple reason, which can be explained using some very fancy drawings. Let's say I have some organization. I have an organization where I have, let's say, multiple, let's say, departments. Okay. And what usually happens in each and every of these departments is that usually because these departments are formed in a business context. Let's say I have a department for HR, right? I have a department, part of HR, which looks into, let's say, recruitment. Okay. Then I'll have a department which is like finance. Okay, finance will have a department which looks into, let's say, income tax queries, or there will be a department who is looking into my claims, right? As part of our office environment, we are making claims for, let's say, medical and LTA, right? Then we may have another department which is kind of a technical department. Let's say this is the infrastructure management, right? They are my IT admin guys, right? So these are guys who are looking into, let's say, Windows administration, or I may have laptops given by my company which is running MacBook, so they are looking into administration of MacBook, or they are looking into, let's say, the configuration of LDAP, right? LDAP is something like that it is a lightweight a directory access protocol which helps us create our, let's say, mail IDs and login IDs and so on. So if you try to understand, if we try to go in depth of each and every department and try and understand what they are exactly doing when it comes to, or if we try to translate that in form of data, we'll come to know that they already have some kind of a fixated structure, right? I mean, this is quite evident, or in each and every organization this is quite clear that all of these departments, although they are doing different functions as part of the organization, there's some fixed structure which is already in place, right? They have a methodology and they have a way in which they are going to work. That's why, irrespective, they have a bifurcations. I can draw lines like HR may not be directly related to finance and equivocally with the technical teams, but they are doing something holistically for the organization, and they have their own set of structures and rules and policies which ultimately result into their data, usually, okay, 90% being in the form of a structured data. Okay, so I can structure those data in form of, let's say, rows and columns. Okay, so that's the advantage I get in a business context. Now this cannot be, or this may not always be true. Example given, there may well be, let's say, there may well be, let me change the color, there may well be a department in my organization which is, let's say, recently formed. It was not there earlier. Maybe it is recently formed. It is formed because of the fact that, let's say, I have a lot of people. Okay, I have a lot of people who are abruptly leaving my company. Okay, I have people who are maybe leaving my company within a matter of 3 months. So HR team is really concerned about this, and in collaboration with HR and the management of each and every division, there is a new, let's say, technology department which has come up in place, and this technology department is actually working on creating, let's say, automated IT chatbots. Okay, they are creating IT chatbots where you can access those chatbots via some phone calls, IVR, or some kind of web URL where you can talk to the chatbots, and in case you are facing some problem, okay, or you want to highlight something, or you want to raise a question, you want to raise a concern. Even when you are resigning, all the question and answer kind of things are primarily done on the chatbot. Then you are redirected to some HR business personnel who is asking you questions and having a one-to-one kind of discussion. Now, why I am taking an example of this is because this is where unstructured data comes into place. If you remember, very in our very early days when we were looking at data structures, we looked into unstructured data, where unstructured data, one of the types of unstructured data can be JSON, where we have key value pairs. Okay, we have keys and values. We have keys and values, and it is quite evident that not all keys will be present in all of the rows or all of the entities which we have. Some rows may have two keys and respective values. Some may have five keys and their respective value. Some may have only one. So it depends on what data this system is capturing, because this system is like a very friendly and kind of schema-less kind of system. Because if you're chatting with somebody, it's like me talking with you, right? I don't have a pre-written script that I'm reading over here. Had it been the case I had a script, had it been the case I had the steps that I need to follow, then I am having a structure, right? Then I know that, okay, for the first 5 minutes, right, for the first 5 minutes in the session, I'm going to only dictate these 5 lines. For the next 5 minutes, I'm going to, let's say, fire 5 SQL queries using a MySQL database, and so on. So if I have this kind of a structure, then my data, or my data hypothetically, is going to fall in this kind of a category where I can really columnize it. But in this case, or in this kind of a scenario where we are talking about people can talk or chat freely, is where you cannot really record that data. Okay, you cannot really record that data in a structured format. So this is kind of unstructured data, right? And this is kind of, let's say, structured data. Okay, so this part becomes my structured data, this is my unstructured. Overall, what is seen in the industry is that structured data forms at least 85 to 90% of my data set. Okay, 85% to 90% of my data is always structured. Even if I have, let's say, 15 to 20% of data which is unstructured, to do any analysis, I have to convert it back into a structured form. This is something which we will look into in case of natural language processing and text mining when we reach that stage, right? I'll also cross check if it is there in the curriculum that we are actually following over here, but it should be there because it's a very interesting field, and it is from where a lot of insights are actually generated. So what I mean by that is, whenever we are dealing with unstructured data, irrespective of whether it's a text, it's an audio, it's a video, so on, I have to necessarily convert it into structure, and then only it gives me the shape, the form, the design that I can go over it. So the reason for this 10-minute introduction was that if I am able to understand how, or what is one of the best, or one of the most comprehensive or easily approachable mechanisms, okay, to look or to work with, let's say, structured data, then it becomes very easy for me to understand why I really need SQL, or why I need languages like SQL, why I need databases like MySQL, Oracle, and PostgreSQL, and so on, and how can I really use them whenever I need them, right? So that's where, in a very strict business context, so this is, I mean, in the next few sessions, whenever we are going to talk about the business understanding, we will only restrict ourselves to business side of things and not into healthcare or any other domain, if you know what I mean. So we will be looking only into the business aspects, right? And in with respect to business aspects, with respect to the implementations actions which are going on over there, it's quite evident that my structured data format is nothing less than the most commonly used structure. And this is where a knowledge of data warehousing, right, a knowledge of ETL, right, and a knowledge of my SQL query language, which is by far, or you can also consider ANSI SQL. I'll also tell you when we reach SQL, maybe not in the test session that we'll have time, but once we reach SQL, we'll come to know why SQL is really the backbone for these two technologies or these two domains, right? So I hope it was clear until this point in time. Let me just clear the diagrams and let me just go back to my notes. What I've done is, to save time, I've already written down some notes, and we'll go through the notes and we'll look at some links, right? We are going to look at some URLs, and I'm going to share these links with you, right? Uh, what we are trying to understand at the first place is what exactly is known as a data warehouse, okay? Because in a business context, whenever we are going to do data analysis, even if we are not going to do, let's say, anything related to machine learning, doesn't matter whether we are going to do anything on the predictive side of things, but even if I want to analyze some data, I must have some kind of a purpose, right? Example given, in our organization, we have, let's say, platforms which are helping customers to be billed. Okay, customers are getting billed, and there are a lot of transactions which are generated because of it. There are a lot of accounts, users which are created because of this. These users are taking subscriptions, right? These subscriptions result into transactions. These users fall into different, let's say, category of being users. Maybe they are X kind of users or Y kind of users. So these all information can help us understand what is the performance of the products that we are selling, right? Let's say I'm part of, let's say, Faber Castle. I'm, let's say, selling my pencils. Okay, so my colored pencils or my regular pencils that I'm actually exporting all over the world, I hope you know this, that Faber Castle is the most prominent exporter of pencils throughout the world. Okay, it's like 1/6 of the world's pencils whether they be crayons, whether they be color pencils, whether they be regular pencils, are actually provided by Faber-Castell. Okay, now this is German company, and let's say that German company has these kind of, let's say, departments, one which is creating so and so product, the other so and so on, and we would like to collate all the data into single place, and my objective will be to then answer each and every question basis some kind of backbone. Right, why I say this is because I need some kind of a backbone to be answered. If I'm saying that I'm interested in looking at product performance, I'm interested in looking at, let's say, revenue, I'm interested in looking at, let's say, the monetary aspects of how my business is actually working, right, then I need this data in some format. Right, I need this data in some format in one single co-located place, and this is what is the objective which is fulfilled by a data warehouse. Right, so overall I can say it is simply a collection of data, nothing more, nothing less. Right, this is just a collection of data, but it has four properties. So if you have a data warehouse and it doesn't have these four properties, then there is a mess. Okay, why is there a mess? Because tomorrow you will need to implement things like MDM, like master data management, and all these, difficult and difficult to understand, difficult to explain concepts. Although because we have a lot of softwares, it becomes very easy. But master data management is kind of an add-on, right? It's like you already have a laptop, but somehow you have not used it properly. You have not used the charger properly, and the laptop is getting overheated, and that's why you are getting workarounds to make sure that your laptop stays cool. Right, maybe you are sitting in the room where you have an air conditioning, so air conditioning was required for you are required to sit in that AC room because your laptop was getting overheated. But your laptop was getting overheated because uh, just a moment. Sorry for that. So you are actually not trying to solve the actual problem. The actual problem is already caused by you here, if you know what I mean. You have done something wrong, I have done something wrong, that my laptop is getting overheated, or maybe my choice of that laptop was wrong. Right, so I'm trying to fix that problem by sitting in an AC room, by using all those kits which are available from Amazon, which cools my laptop or which tries to drain out the heat which is produced in my laptop and so on. Right, now that should not be the case. I should have an objective. In this case, my objective, I'm working as a data analyst, I'm working as a data engineer in the company Faber-Castell in Germany or in India, and I would like to ensure that my organization's data is structured and collected at a certain place, so that using that data I can do X, Y, or Z use cases which are related to product performance, which are related to revenue, which are related to the monetary aspects. Right, that's why these four properties are really important. Let me just zoom in a little bit. So the first property, it should be subject oriented, as I said. It should contain information about a few well-defined subjects rather than containing information about the entire enterprise. Example given, I may have a very big organization, and let's say in this example of, let's say, Faber-Castell, it may or may not be a very big kind of an organization. But to be honest, if I'm only going to look at, let's say, performance of my products or the pencils that I'm selling or the revenue, do I really need to know who all are the employees who are working there and how happy or unhappy they are while being part of the organization? May not be, because their unhappiness may have an indirect effect on my, let's say, production. But if I am only going to be concerned about, let's say, per day, what are my sales, what is the revenue, what is the profit, what is the performance, then I really do not need to know at the first place what is the sentiment of my customers, or what is the sentiment, okay, what is the sentiment of my employees. I may need to know what is the review which is, or the feedback which is given by my retailers. Right, I can store that. But if I'm only going to look at transactional information, then I must be subject oriented. Right, I'm not going to capture everything which is there in my enterprise. I may not capture transactional data as well as the HR data. Right, so I will be capturing transactional data only in this case because I have a context. My context is I'll look into the product performance. Right, the second thing is it is integrated. Right, it is integrated. Now the subject oriented and integrated, these 2 points are going to collide with each other, because subject oriented says you have to concentrate on one subject. Good. Integrated says you have to take this data from various different let's say departments. What I mean by that is, let's say Faber Castell has a pencil, okay, HB pencil kind of, right? The pencils which we have used in school. Now if we have a department which is producing HB pencils, then I'm going to take the data from that let's say department which is D1. There is one more, let's say, department who are concentrating on the crayons, then I'll take the transactional data from that department, right? So this is what I mean by integrated. I have one place, right? I have one place where I have integrated all the department's data, but the data that I have collected or integrated, they are all to certain extent belonging to transactions and monetary aspects and so on, right? The third thing, the data is non-volatile. You cannot change the data without a valid reason. Example given, if let's say, if let's say it is a very confusing kind of a concept at the first place, but this is a fact. You do not update your data unless it was updated by the system. This is just an example. There can be many other use cases. Example given, let's say that I've captured the transactional details of a certain day, right? And by mistake, there was an error. Okay, there was an error in the data entry. Okay, maybe I've missed a couple of, let's say, values post the decimal. Okay, maybe the sales on that day was 124 actually, but the way the person wrote it by hand and somebody entered it into an Excel sheet, or somebody entered it into the SQL database using an insert query, was that he or she entered it as 154 or 114, right? Now if it is entered already wrong, am I going to update my data warehouse at a later date? Oh, since I found that it is wrong, it was captured in a wrong way, let me just update it. The answer is no. The answer is no. You have to figure out a way. You have to figure out a way in which you can capture the history. This goes back to the fourth point, time variant. We may want to look into this. If you want an example, I can give that to you. So you may have to look for solutions where you capture both the data. Also, the error data which is already inserted in the database, don't update it. Add another row. Okay, add another row in the table, add another entry in the table in the data warehouse, which captures the right information, and somehow you use some kind of flag to identify which was the old information and which was the new information. Like, this concept is otherwise known as slowly changing dimensions. This is part of ETL. We have not reached there. That's why I'm not explaining it to you right now. So slowly changing dimensions is a concept which we use in, let's say, data warehousing, which can help you do this kind of an activity. But what I mean, what I exactly want you to do, or what is something that we must do, is that we should not delete the row. Okay, on that day somebody captured the data incorrectly. It's a human error. Okay, let's accept it. We are not going to delete it from the DB. We keep the old data, we keep the new or the correct data as well. We figure out a good mechanism to understand or identify, right, that we have captured the new data. This is the right way to understand which is the wrong data, which is the right data, right? Fourth, and the most important, time variant. Data warehouse must contain historical data. Now, this is something, okay, I see Mugdha has raised her hand. Go ahead, Mugdha.
Sudha, just one question. Like for
Yeah,
the non-volatile value, if we are like making the flag and changing the values, right?
yeah,
So will it not like happen after a certain point of time? We will be overloading the data warehouse with a lot of
yes,
data which is
yes,
not required. Maybe
mm,
suppose there are hundreds of human errors,
yeah,
and
yeah, true,
yeah, it can happen.
yeah. Yes. So
So
in
in
that
that
case, we will
case,
have to
how can
figure
we
out
resolve
some
it?
ways. So in that case, we'll have to figure out ways like data retention. Example given, let's say I'm capturing data, and that relates to point
Right.
number 4
Okay.
as well, right? I have historical data, and let's say I have the data for the last 5 years. Okay, but what I do
Right.
is that
Right.
within that range of last 5 years of data, I'm going to create a policy that if there were human errors which are older than the last 18 months, I'm going to get rid of them.
Oh, okay. Okay. Okay.
Right, so that
Okay.
kind of a
Got
technique
it.
you can use,
Fine.
but that is dependent on how much, let's say, budget you have, how much infrastructure you can really scale up to, right?
Okay.
Right. But the most important point, the fourth point, this is also as important as the last 3 points. As I was saying, a data warehouse must contain historical data for analysis. Please don't tell me that I have the last 6 months of data. Then you don't have a data warehouse, just have a database. The 6 months of data is kind of a data which you retain in a transactional database, which is used as a backbone for, let's say, billing purposes. If you want to have a data warehouse, you should have, let's say, people talking about data warehouses will say, I have 3 years of data, 5 years of data, 7 years of data, 10 years of, let's say, stock trading data, correct? I have the last 7 years of, let's say, Faber Castle sales of my pencils. That's a data warehouse, because that is the only way, okay, that is the only way you are able to solve two problems. One is, for your data analysis, you have historical data to look at the trend. We are going to understand this problem or this facet when we look into analysis techniques like time series forecasting. Because if I want to predict, let's say, data or sales after a certain point in time, I need a good amount of backbone so that I can predict the rest. If I don't have that backbone, I won't be able to estimate the new values or the next values, which are dependent on date and time, right? That is really, really required, right? So this is really important. The organization must be prepared to accept this. You as a data engineer or an architect or a data analyst should be able to convince the organization and the management and the architects there. I'm sure they will already be aware of this, but if need be, we need to be very conjoint, and we need to be very direct in saying that if we don't have X years of data, then we are not really doing justice. Okay, we're not really doing justice to the possible analysis we could have done with that data, right? Now, keeping these four in mind, let's quickly go through the rest of the notes. One of the primary methods, right, the one that we use to model a data warehouse, or how we are going to design a data warehouse, is by making sure we use dimensional modeling. There are various types of dimensional modeling, but the most common and the most basic type is what uses two simple concepts. One concept is known as facts, and the other concept is known as dimensions. Okay, which are basically, okay, different types of variables. This is nothing more, nothing less. Okay, dimensional modeling talks about what type of data I'm going to store in my data warehouse. Accordingly, I'm going to model. I'm going to create the ER diagram. If you remember, when we were in college and school, when we were studying the basics of, let's say, RDBMS or any database management system, we studied in entity relationship diagrams. And the way, or one of the considerations we are going to take in case we are designing the same thing for a data warehouse is dimensional modeling, where we are going to talk about facts and we are going to talk about dimensions. Now, what is a fact or what is a dimension? Even the most important question, how am I going to create that ER diagram? That ER diagram is otherwise in data warehousing terminology known as schema diagram. So if you're talking to let's say a developer who is a database developer, he's not a data warehouse developer, and or a database developer for, let's say, an application which is like a billing relationship management application, and in the backend we are going to have some kind of, let's say, Oracle DB, which is going to in real time, as and when there are transactions happening via some kind of a credit card, it is going to enter the or update the details in the backend in the DB. That's a database. It is not a data warehouse, because it is a very, very small part of your entire organization. You may not be able to use it to answer all the questions you have, or it will not really suffice with those four assumptions which we had, right? So to do the modeling, we are going to use, let's say, schema diagrams, and they're going to look something like this. We are going to have tables, we are going to have views, we are going to have entities, and then we are going to link them with one another with the kind of, it's a relationships that they have, right? So this is a schema diagram that we are going to go through. Obviously, we are going to take some use cases, we'll go through them, but these entities which you see over here, right, have some kind of, let's say, relationship. So these are the entities and the relationships they have. So this is in the database world known as ER diagram or entity relationship diagram. In case of data warehousing, it's known as a schema diagram, right? And this schema diagram contains either facts or it is going to contain either the dimensions. The facts and dimensions may be stored in different tables, or it may be part of the same table. So a single table, a single entity, or a single view may have both facts and dimensions or the combination. So ideal condition, it is a combination. Each and every entity will have a combination of facts as well as the dimensions. Now, what is exactly a fact or what is exactly a dimension? Fact is as simple as numerical data. Okay, it means, let's say, all the sales, okay, all the sales that I have done for my pencils in the Faber Castle in the last one day, in 1 month, in 6 months, all the transactions, right? So let's say I have a date column and then I have the amount column, or I have the quantity sold and so on and so forth. So this is something, okay, this is something which is known as a fact, because once this entity or this entry, this event has happened, there is no way you can change it, right? Imagine you going into a supermarket and you are making a payment via Google Pay. Okay, you have already made a payment, the money is deducted from your account. Can you revert that event? The answer is no. The only way you can take care of it is to initiate a refund. That refund becomes another transaction, right? Because the first transaction was, you can categorize it as a payment transaction. The next one you can categorize it as a refund transaction, but you cannot say that I have reverted the payment transaction in the database. You cannot do that, I'm sorry, right? So this is why it is known as fact. So it does not change. It is huge. It is like transactional data, each and every entry for each and every date and time, right? One very column or very common column or aspect of a fact data is that we always have a date and time column, right? We always have a date and time column. What is the dimension then? Dimensions are the metadata. Data which is explaining some other data attached to the fact variables. Example given, let's say I have a table or an entity which is providing the fact for all my transactions that I have done in any store in, let's say, Big Bazaar. And there is one column which is getting stored, which is let's say the counter number. So on which billing counter I was there, counter number 10 or counter number 9, counter number 8, and so on, right? I may have a dimension data which is going to tell me counter number 10. Okay, what are the payment methods which is used over here? Does counter number 10 have Paytm? Does counter number 10 have a credit card machine? Does counter number 10 have a monitor which I have bought from, let's say, Dell, and so on? So I can have, let's say, information in some format like this. Let's say counter is one column. Okay, PA refers to Paytm, CA refers to card, DE refers to the Dell monitor. So counter number, let's say 10, I have Paytm, so I'm going to call this one. I have credit card, I'm going to call this one. I don't have a keyboard from Dell or a monitor from Dell, I'm going to call this 0. So this metadata information, okay, a very rough kind of an example this is. This metadata information is related to this fact table. So I can clearly join. This is something of a very important operation which we have in SQL. I can join these two entities, entity one, which is fact, storing all the transactions, and entity two, which is a metadata of all my cash counters, or the properties of the cash counter. I can join them to try and find out, let's say, in which kind of my cash counters am I having more transactions. Are people more inclined towards counters with Paytm, or are people inclined more towards counter with a credit card, or a combination of these two, right? So to answer those important questions, we need to store these dimensions in a separate entity, and we can analyze the dimensions itself as a separate entity. We can analyze the facts itself as a different entity, and so on, right? This is the basic of, let's say, data warehousing. Any data warehousing will have facts and dimensions. Simple. Facts and dimensions, as I said, used to do dimensional modeling. Now, just that we were looking into that database thing and data warehouse thing, we need to understand, first of all, quickly, what is the difference between these two things? A transactional database, or the database developer that I was referring to, he or she is working in an OLTP, or online transaction processing system. Okay, the major difference between online transaction processing and the other part or other side of the coin being OLAP. OLAP is something which we are going to use when it comes to data warehousing. A data warehousing follows an OLAP kind of a structure, OLAP being the acronym for online analytical processing. The major difference being the name itself. OLTP is used for day-to-day transactions, OLAP will be used only for analytical purposes. If I'm going to answer analytical questions that we were answering until the last session, for the last 10 or 15 sessions, like we had some advertising data, and then basis that advertising data, I was trying to figure out, if I invest 1000 US dollars in the TV based advertisements, how many units am I going to sell? If I remember the output or the model, let's say correctly, maybe Rohi or Sarangs can actually correct me if I'm wrong. $1000 investments in TV advertisement resulted into some kind of, let's say, 4600 units being sold, right? So that was what my analysis was, but that was a regression that I applied. But to apply that regression, I need to have the data that I'm going to explore first, the data that I'm going to visualize first, and then I'm going to apply some kind of statistical model, and I'm going to get the output, right? So OLAP is for that purpose specifically, where I'm going to use analytical use cases, analytical functions, and I'm going to make use of them, right? So when it comes to OLAP, uh, there is one thing that is quite essential for us to understand. I'll maybe move this thing, facts and dimensions thing, a little bit on top, because facts and dimensions is something which we have already explained. But let me just take this and put it over here. So what this a paragraph that I have already written here is saying is that facts and dimensions are just the two key elements, as we saw in dimensional modeling. They involve a typical problem might involve multiple databases with many variables, and we may not be interested in all the variables, but just a combination of some facts and some dimensions forming my schema diagram, right? So that's the uses of facts and the dimensions, which we are going to use in the context of OLAP and not OLTP, because we are interested into data warehousing, right? We are not interested into transactional processing, right? Now, keeping this in mind, one of the most let's say widely used dimensional modeling technique is star schema. Okay, star schema is where it is a schema. Okay, I see Mugdha raising her hand.
I'm so sorry, Sudha. I
No, go
just
ahead.
wanted to know, like OLTP, can we convert OLTP to OLAP at some point of time? See,
Yeah,
because we have the day-to-day transactions in
yeah.
OLTP, and then the same can be after maybe a year or so. We can convert it to analytical purposes also. Is it like that?
Yes, yes. But what I would like to uh, give an answer in this context is that when we are doing, let's say, data warehousing, or when we are using ETL is something which we are going to look next, right? Maybe not in this session because we are
Mhm.
already out of time. But when we do ETL, or when we are loading or ingesting data in a data warehouse, we are actually converting data from an OLTP into a lab. So the
Hmm.
answer to your
Right.
question is, if you already have an OLTP, you don't mess with that. Okay, you don't change it. So what you do, you
Okay.
create an OLAP, which is a separate entity, separate, let's say, database, separate installation, and you
Mhm.
load data from OLTP into that separate entity using these kind of, let's
OLAP.
say,
Okay.
dimensional modeling, so that now you have both an OLTP as well as an OLAP, right? Because you are not going to survive without
Okay.
an OLTP,
Right. Right. Okay. And
right?
basically, dimensions is data about data, basically
Right.
metadata, right?
True, true. But please don't
Okay.
consider them to be a metadata about your entities, right? Let's say I have a
Okay.
table where I have saved, let's say Rohi has created 5 tables. Okay, but
Mhm.
table 1 is for transaction, table 2 is for, let's say, users and so on. That is also a metadata. But that's a metadata
Mhm.
of the tables which I have in the database. That is
Tables.
not a dimension,
Right. Right. Okay.
right?
Got it.
Okay. Uh, I think let's just quickly look into this star schema, and maybe we can wrap up and then we are going to continue tomorrow. So part of dimensional modeling, there is a technique which is known as star schema. We are going to look into that in depth in the next session as well. But a dimensional modeling techniques is where star schema comes handy, right? And star schema is one of the ways in which I can really design my schema, where I can simply draw a diagram maybe quickly, and then we can make a close. So let me just open a new page and let me take my pen. So star schema will look something like this. Let's say I have my stores. Okay, I have my stores. Okay, stores information is there in some table or some view. Okay, this is a dimension. I have another dimension, which is the time. Okay, why we need time dimension, we are going to discuss this in great depth. Okay, don't worry right now. But third, let's say we have a dimension called product. So we have the metadata information related to all my products. I have metadata information related to all my stores, and I have some metadata information related to date and time. And now I have a big fact table. Okay, I have a big fact table, which are all my sales that I have done. Okay, star schema is where I have this fact talking to this dimension, talking to this dimension, and talking to this dimension. Okay, these dimensions 1, 2, and 3 may or may not be talking to each other. Ideal condition, strictly speaking, they may not even know that each other exist. Store may not know PR exists, PR may not know time exists, but sales knows that 1, 2, and 3 dimensions exist, and it's going to use them or join with them, okay, to be used for any further analysis. It's a bit confusing at first. Let's try to look into it in depth in the next session. Yeah, let's continue from tomorrow. Thank you so much.
Okay.
Thank you.
Thanks a lot.
Thank
Thanks a
you.
lot. Thanks everyone.
Thank you.